Nobody can hear me because nobody's in yet. Okay. So Connor, Junior, John, Gabe, Kyle, Max, Adam, Cameron, Ian, Sadie, Peyton, Cindy, Gwen, Tyler's not here yet, Ava, Abby. Welcome everybody, welcome. Please open up this slideshow. We are gonna get started. I'm gonna wait another like 3 seconds though, because there are a few people that are not here. So I just shared my screen. Give me a moment. Today is gonna be like, I know I always say this, but like we're really gonna finish early today because there's like nothing in this lesson. Not nothing, but like very little. Jello.
Hi, sorry to interrupt.
No, it's fine.
Ricardo's gonna be in my room for the day. If you have any work, if you have any work for him.
So his is there. If he wants to zoom in, he can.
Okay.
I would suggest him zooming in because I don't think. I mean, like today's lesson's not that bad, but like I think it'll be good for him.
What time does he have?
11:29.
11:29. Okay.
And then I'm gonna be down there anyway, so I'll just pop in and be like, "Yo, like, hey, jump in."
Okay. Awesome.
And then we'll do that.
All right.
Yeah, no problem. Thank you for that. I mean, not like just thank you. Let me know if you need anything. Good morning, everybody. Let me grab my participants list. We are missing Nassim, which I'm hoping he jumps in at some point. We got our chit chat going. Let's get started. Why am I singing? I don't know. Let's take a look at our. Let's take a look at our slideshow for today. Our slideshow for today, we are looking at. Let me just get prepared. I'm sorry, guys.
Hey, Mr. May, can I borrow your remote for 1 second?
Yes.
Also, so that's just, we're just gonna
keep track, yeah.
Because like, it's too, I think that'll be fine, but yeah, that crew needs to be kept track of it.
Yeah, I think that's a good idea. So, Pate, if you want to, oh, she's not here. Let me let her in. Let me turn my camera up. So, Pate, you can watch the recording later if that is going to be better for you. If you want to just watch and listen, you can, and then the recording will be up later. Okay, let's take a look at our warm-up for today. So, this unit, first things first, how are we feeling with this unit so far? Do we feel like, because I feel like teaching it, it's very similar to the things that we've done in the past. We're just throwing some new vocabulary terms on it. We're maybe, instead of writing y equals, we're introducing function notation. So this unit so far, in my opinion, is very similar to things we've been doing in the past. So that's pretty cool. So what you need to do for today, looking at this warm-up, I don't want you to look at it and be like, well, we've done this before, because we've done similar things to this before. So don't be like, oh, maybe it's not what I'm thinking. It's definitely what you're thinking. So it says, consider the equation. We're given this equation right here. Okay? It says, what values of Q would make the equation true when P is 7, P is 100. So you're going to take 7 and 100 and do what with them? Plug it in and solve it. Good. Then we are going to do the same thing, but this time we're given our Q values, and you're going to solve for those values. Thank you so much. I want you to take 2 minutes right now to complete this warm-up slide. And I might actually do like 1.5 minutes instead, because it shouldn't be too bad. Grab calculators if you need them. You are solving these equations for the indicated variables. Mr. May always leave her timer places. So like I said, I'm going to give 2 minutes. I don't think you're going to need 2 minutes. I might start this a little bit early. So just an FYI to you guys here. Let's not open this window anymore because it won't close anymore. So we can do this one here if we need to. There might just a little bit. Let's let this hot air out. And then we can close it up if it gets too cold. Okay. Very cool. So Pate, did you hear what I said before? You can just, if you want to just sit and watch, you can. Oh, perfect. Thank you. Hey, Nassim. So we are on slide number 2. It is as simple as you think it might be. Take a look and get started with it. Oh, okay. So count. Perfect. Let's take a look. For number 1A, what were we thinking for an answer for that guy? Connor, first of all, what'd you do?
I plugged in 7 for P,
Okay.
and I did it out, and the right side of the equation is 9.6.
9.6 is equal to
Q.
Q. Very good.
Q had to be 9.6.
9.6. Very good. Nice job. Second one here, when P was 100, we're going to take that same equation and we're going to multiply this time by what? 100. And Adam, what'd you get for a value for this guy here? 84. What do we think? Agree, disagree? Very good. Nice job. When you plug it in, multiply, you get 80 plus the 4 is 84. Very nice job. Now, this time, when we look at this second section here, we use that same equation, but what are we plugging in for this time?
Q.
The Q. So this one, we're going to say 12 is equal to 4 plus 0.8. That variable was P. What did we do? What did we get for a value here, Max?
10.
So what did you do first?
I subtracted 4 from both sides.
Very good. You get 8 is equal to 0.8 P. Then you
Multiplied both sides by 10.
multiply both sides by 10.
Or divide both sides by 0.8.
Divide both sides by 0.8. And you get a value of 10. Very good. So this one was, the second section was a little bit trickier because you had to sort of isolate and get that P by itself for that last step. Good. Then what did we get for a value of when Q was equal to 60? What did we get for a P value? Kyle? 70. Very good. So this time you take this 60, you plug it in for your Q, and then you isolate, get that P by itself. First, you undo that positive 4, then you divide to get rid of that 0.8 times the P. Good. Everyone follow what we did here? Perfect. Listen, I don't want to make any assumptions because this is not too bad, but I don't want people to fall behind. So let's take a look at our targets for today. Our big piece today is we're going to be using technology, so Desmos, which is a website, to use technology to graph a function given that's the one that's given in function notation. So it's going to be very similar to when we graph them with like y equals, but we're going to be looking at function notation this time. And we're going to use the graph to find the values of functions. So just like we did last time when we were graphing equations and we were finding values, we're going to find some values on those equation lines again. Then we're going to be able to know the different ways to find a value of a function. So different ways. You can plug in solve. You can use some graphing tools that we're going to talk about today to find some values. Then we're going to be able to know what makes a function a linear function. I've introduced that idea, that vocabulary word of a linear function before. Today we're going to hit that, nail it, get it done, really nail down what a linear function is. Okay? So, slide number 4. You're not going to be writing anything on number 4. We're just introducing this scenario that we're going to be using for all of class today. So, a college student is choosing between 2 data plans for her new cell phone. Both plans include an allowance of 2 gigabytes of data per month. So, she gets 2 gigs. The monthly cost of each option can be seen as a function and represented with the equation. Option A of x is equal to 60. Option B of x is equal to 10x plus 25. What I want to do here, you don't need to write any of this down. We're going to have a little bit of a discussion about these 2 equations. When you look at option number 1, what do you notice about it? What do you notice about option number 1? Max.
I notice that no matter what x value you have, you will always have an answer of 60.
Okay, so whenever you look at however many gigabytes above the 2 that they give you, you spend, it's always going to be 60. So in the context of like cell phone plans, what kind of cell phone plan is that? What do you think? If it doesn't cost, if there's no X there, it doesn't cost you per the gigabytes above, what does that mean, Ian? It's unlimited. It's an unlimited plan. You can use unlimited amount of data for that $60 a month. Good. I just threw those on here so that we have a little bit of discussion. So now when we look at option 2, this guy's a little bit different here. So if you just use 2 gigabytes of data, 2 gigabytes or less, how much money is it going to cost you per month?
$35.
If you just use 2, you don't go above 2, because that's how much they give you. Think about it. How much?
25.
25. And why do you say 25?
Because the 10 is for how much you go over.
Good, because that X represents the number of gigabytes above the 2 that they give you that you use. So like if you use 3, it would be like 1 would be plugged in for X because that's above the 2. So then it would be 35 if you go 1 gigabyte over. So if you use less than 2 gigabytes or maybe even equal to 2, it'll be $25. 2 or below. If you use above, how much is it per gigabyte? $10 per gigabyte. Good. So every extra gigabyte is $10. Okay? So that's what I wanted us to sort of have a good understanding of. Okay? So first one's unlimited. It's always going to cost you $60. They might throttle your speed, but you're still only paying $60. Then the second one is a little bit cheaper if you plan, like for old grannies, like my grandma would definitely want option B because she doesn't use data. Just saying. So the function, in each function, the input is X, represents the number of gigabytes of data used over the monthly allowance of 2. Okay? So now we're going to use these two equations and we're going to answer some questions, create a graph, and find some values. Okay, so let's scoochy scooch down to slide number 5. Okay, on 5, we have our two options again, option A, option B. And it says the students decide to find the value A of 1, B of 1, and compare them. What are the two values? So what are the two, if we have A of 1 and B of 1, what would our two values be? And what does it mean in the context of the story? Take 1 minute right now to look at this question. And then if you finish early, you can start to look at number 2 as well. Okay, what is A of 1? What's the value for each of them? What does it mean? And then you can start to look at A of 7.5. Ooh, nice job. Very good job, Gabe. Taking another 25, you're doing great. Okay, let's come back together. Take another second to finish your thoughts. And I want you to think about this question first. When I say A of 1, what does that mean in the context of the story? What's happening when you have the value A of 1? John, what does the value A of 1 mean in the context of the story first?
They use 1 gigabyte of data.
1 gigabyte of data? Is that specifically what it means? Because the X doesn't represent the number of gigabytes of data used. X represents the number of gigabytes what? Each function, the input X represents the number of the gigabytes of data used over the monthly allowance. So he didn't use 1 gigabyte of data here. How many gigabytes of data did this person use? 3. Because the X represents not the number of gigabytes, the number of gigabytes over the 2 that you get every month. Do you see the difference there, John? Nice job. So this is representing when they use 3 gigabytes. Okay? So how much is plan A going to cost when they use 3 gigabytes? 60. Why is that? Because it's unlimited, right? And it's always going to cost you 60 what? Dollars. Make sure you have a label on there so you know what you're talking about. When we talk about word problems, we always give labels to things. B of 1. How much is B of 1 going to be? What do we think? What do you think? Adam, how much is B of 1 going to be?
35.
35 what? Very good. And how did we calculate $35? What did we have to do there into that equation that we were given, Kyle? Very good. B of X, or actually we would write this as B of 1 is equal to 10 times 1 plus 25. 10 plus 25 is equal to B of 1. B of 1 is equal to $35. Okay? We've done this. The new piece of it is throwing in the function notation. Okay? Very good. Now, B of 7.5, A of 7.5. After looking at some of her past phone bills, she decides to compare 7.5 gigabytes, A of 7.5 and B of 7.5. First question, how many gigabytes of data is she going to have used in total? Max.
9.5.
Good. Use 9.5 gigabytes. Okay? How much is plan A? Gabe, how much is plan A going to cost when we do A of 7.5?
Still 60.
Still $60 because it's what? Unlimited. So I would use 60 and then I would put like a dollar sign in front of it so that you have a label on it. Good. Now comes a little bit more of the tricky one. Plan B. B of 7.5. How much money is that going to cost? Connor? $100. And can I have, Gwen, how did you calculate how much B of 7.5 would cost? Plug it in, very good. B of 7.5 is equal to 10 times 7.5 plus the 25, 75 plus 25. B of 7.5 is equal to $100. Very good. See what we're doing here? Okay, perfect. Now I want you guys to describe, we've talked about what each of these plans means. Now I want you to, in words, tell me what does each plan mean? What does it represent? How much does it cost? What's your rate of change? What's your initial value? If you spend less than this, then it'll cost this. It will always cost this. Take a minute and a half right now to explain, describe each of these in the context of the phone plan. Each of these phone plans, what does it mean? Give me as much detail as possible.
Can I interrupt for 1 second? Sorry guys to interrupt because it sounds like a great lesson. 2 things. First, no more using bathrooms during Encore. I don't think you guys have an issue, but we're letting everyone know. So you go before Encore or after Encore, unless it's an emergency, obviously then you go. Don't forget to use your Google Forms to sign out as well, okay? Got it? Thank you for the thumbs up. Thank you for the head nod, Cameron. Thank you. And you guys, I just want to say nice job on your attendance. You guys are killing it in February and
I know, right?
March. Keep it up. You will be getting that special breakfast. I'm just waiting to hear back from the food supervisor to see what your choices are, so you'll get to choose, okay? All right, keep up the good work, guys.
Thank you, Mr. Cardone.
Thank you.
Have a great day. Okay, I'm going to start the timer now. Give me a description in super, super detail what each of these plans means. Come on. Oh, did you finish already? Perfect. Let's just wait that minute because people were listening to Mr. Cardone and I want to make sure everybody has the opportunity. I know that we've talked about this, so now it's just your time to put it down into words. What does each of these plans mean? What does it cost? What does our variable represent? Wonderful, wonderful. We're taking another 48. If you want to move on, you can start to look at some of the other slides. You can start to look at the graph down below if you'd like. Let me make sure I have everybody checked in. And that's only from the design. Welcome back, Peyton. We missed you. Okay, let's come together. Option number 1 or A. Who can tell me in their own words, what does option A mean? Ian.
It said that the data plan is unlimited, so you can use as much data as you want for the cost of $60 a month.
Very good. So that data plan is unlimited. No matter how much you use, it will cost you $60. Very good. No matter how much data you use, it will always cost $60. Very good. Now, this other one is a little bit more complicated. There's probably not complicated, but there's more information that we have here. Option B here. Who can give me one way that they described option B? Connor.
You get a limit of 2 gigabytes of data, and if you go over it, it's $10 for every other gigabyte.
So I have a limit of 2 gigabytes of data, which will cost me how much? $25. Then for every gigabyte over I use, it costs me $10 additional. Good, nice job. Every gigabyte above 2, I'm going to write it up on the side here, will cost me $10 each gigabyte. Good. Is there anything else that we need to add to that description? Anything at all? I think it looks very good to me. So I wrote it down to here, and then I finished writing it up on the side up here. Okay? Next piece, we are going to be creating a graph for both of these scenarios. Once again, we know how to make graphs, so this shouldn't be super duper duper tricky. I'm going to leave these 2 descriptions up here. Let's take a look at the graph section here on the next slide. Actually, I'm going to leave it up for another 20 seconds. Nice job, Gabe. I already said that, but. Okay. So here we go, looking at 6. Graph each function on the same coordinate plane, then explain which plan you think she should choose. There might be like different criteria of when you would use each one though. So I have my points down here. I have some lines. Let's graph option A first. So who is going to walk me through graphing option A? Option A, if we remember, let me just write the equation down. A was A of x is equal to 60. How would I graph that? My output is always going to be 60. So which, Max?
I would put one point at 60 at 060, and I'll put another point at 960, and I'll put the line connecting to the 2 of those.
Very good. So y. So I'm written a of x is equal to 60. When we have function notation, that's like saying what is equal to 60. Before when we used to write equations, we would say what is equal to 2x plus 5. How else can I write this equation? If it's not in function notation, it would be what is equal to 60?
X.
Not x.
A.
Y is equal to 60, yes. So this means the same thing as y is equal to 60. And when we had y is equal to 60, that means it needs to cross which axis? When y is equal to a number, what axis does it cross?
X.
The y-axis. It crosses the letter axis that it has in its name, right? Y is equal to 60. So you can plot those points, use this red line to connect them. Once again, you're going to want to grab it, sort of swing it up, bring it directly across, creating a horizontal line. Good. Now, the next one is a little bit more tricky. It's 25 plus 10x. How did I graph this guy? Or how could I graph this guy? What do I start with? Ian?
I'll put a point at 0, 25.
Very good. 0, 25. And then I need to extend my line using what? Extend my line using the equation. And what in the equation tells me how to extend it? The 10x. That's my rise and my run. So my rise is going to be 10. My run is going to be for every 1. Very good. So from this 25 to, or 0, 25, sorry, Mr. Main, we're going to go up 10 over 1. Grab a point off our pile. Up 10 over 1. And we got a nice sort of ish point right on there. Then what do I do? Connect them. Exactly. You take your line, you connect them. So you grab it, you swing it. It's not letting me swing it. Let's try it again. I'm going to line it up and then I'm going to swing it back down now. Boom. Okay. So now I want you to take 1 minute in the box to tell me when would you choose each one of these plans? I know which plan I would choose, but that's just me knowing my usage. Okay, Peyton told me which one she would use. I know which one I would use. I'll be in the same boat as you, Peyton. Woo! Okay, let's take another 15 seconds for ourselves. Ooh, nice. Gabe said he. Nice. That's funny, Gabe. That's good. Not funny, but it's good. That's a good explanation why. Okay, so Junior, if you were to choose Plan A, when would you choose Plan A if you were like a strategic person?
Like up to 4 gigabytes each.
Good. So if you plan to use, so you would choose A if you use up to 4 gigabytes?
Or no, up to, if I use, for Plan B, up to 4.
Oh, okay. So Plan B would be if you plan on using less than how many gigabytes? It's 4 extra gigabytes. So how many total gigabytes? 6 total gigabytes. If you plan on using less than 6 total gigabytes. I don't know, like the capitals of gigabytes. I don't know. Now you would use Plan A when what? Max?
If I would use more than a total of 6 gigabytes?
Very good. Use Plan A if you plan on using more than 6 gigabytes. Good. So we want to be, when we have this system here, this is a system, we want to say, when is it going to be cheaper to use this one? When is it going to be cheaper to use this one? Good. Nice job, guys. So now, we are going to skip over slide number 7. I'm not a fan of that one. And we're going to jump right down to 9, but we're going to use a link on 8 to get there. So we're going to skip down to 9. We're going to read the directions, and then we're going to go back to 8. Okay, so now what we're going to be doing is we're talking about only function b now. So that one where we had that rate of change attached to it. When we said we had b of x is equal to 10x plus 25. Okay? So function b is defined by the equation b of x is equal to 10x minus or plus 25. Use graphing technology to first find the value of each expression, b of 6, b of 2.75, and b of 1.482. Let me show you how we're going to calculate those. Question, before we use the graphing technology, if you were given this question, how would you solve this just with what you know now, before I teach you something new? Junior. For the x, very good. You take those 3 values and you plug them in for x. Now, let me show you a different way that we can calculate these using graphing technology. So what I want us to do is I want you guys to go back to slide number 8 and click on the little image and it'll take you to Desmos. It'll look like this. And now we're going to type the equation in there. We're going to say b of x is equal to 10x plus 25. And then you can click out of it. Okay? So now it's kind of hard to see these things. So now I'm going to show you how to change your windows. So it's going to change these labels on the axis here. So what I want you to do to change your windows is click on the little wrench up at the top, left, right, little wrench on the top, right. Come down to where it says x-axis. Click in the first box here, delete the number, and type in the number -1. Okay? Then when we go to the other side of those symbols there, you're going to erase that number in there, and you're going to type in the number 11. Okay? Then I want you to come to the step, and I want you to write the number 1. Okay? Then we're going to go down to y-axis. Come into that first box. I want you to type in -1 again. But now your upper number here in this inequality is going to be 120. This step, I want you to leave it blank because it defaults to a good number. Okay? So now your graph should look like this. Let me get a thumbs up or a message in the chat if yours does not look like this. Okay? Okay, so now let me show you what we're going to do to calculate some of these values here. So when we have these, when we look at b of 6, so that means when my x is equal to 6. So I can calculate that one without doing anything. So if my x is equal to 6, which axis am I going to find 6 on? The x-axis, because inputs are x's, and you can follow it up, and you can write x is equal to 6 in this guy down below, and it will graph 2 lines here now. Where they meet is that value. So what is my value at an x is equal to 6? What's my value going to be? 85. Very good, Abby. So when you want to find an intersection point on a graph, you create an equation line, x is equal to in that value, and then you calculate the intersection point. Do you guys see how I did that? So then I come back here. What's my value when x is equal to 6? My b of 6 is going to have an output of how much? 85. Very good. And we're talking about what in this scenario? 85 pickles, pencils, dollars. Okay? So now what I want you to do is I want you to use that same technique of doing an x is equal to line, calculating the intersection point for these two guys down here. Okay? I want you to take a minute and a half right now to calculate these two guys. And then I want you to think, how might you do how might you find when the b of x is equal to 95? The output is equal to, or 93. I want you to think about how you might do that graphically. Take a minute and a half to calculate these two and take a look at the second one. You can plug it in and solve, but when you get some of these crazy decimals like this, you're not going to want to do that math. Start to think about, if you finish early, number 2 down here. Nice job, Peyton. Woohoo! Very nice. We have another 41 seconds. Okay, here we go. 10 more seconds. Okay, so you go into the gear up top here, Gabe, the little wrench guy, and then you're going to do these numbers here. I'll leave it up for a second for you. Okay, so in Desmos, you could have, like in the real world, you could have plugged in and solved. We're using this tool now, Desmos, to see if we can sort of quicken the steps that we have to take. So if I wanted to find out when x was equal to, when b of, the output of b of 2.75, what could I do in my Desmos here to calculate that point really easily? Plot a line of x is equal to 2.75, and then you calculate the what? The intersection. So what was the output when the input was 2.75? 52.5. Very good. 52.5 what? $52.50. Very good. And then the last one, we wouldn't want to actually calculate that decimal. That's 3 decimal points out. We do an equation line of x is equal to 1.482. And then we calculate the intersection by clicking on the intersection point right here. What did we get for an output here? Who can tell me? $39.82. Very, very, very good. So now we're given instead of given that x value, we're given the whole output is equal to 93, 42.1, 116.25. How do you think I can calculate it with Desmos this time? Connor?
You keep the same equation.
Okay.
At the top the first time. Then under that, you write b of x is equal to, and then the number it gives you.
B of x. Oh, wait, let me put it in parentheses, sorry. B of x is equal to, and then what was that first number that we got? 93. Very good. You could have also written it as, Ian? Very good. Y equals 93. Very good. Both of these mean exactly the same thing. And in Desmos, you could write it either way. Good. Nice job, Connor and Ian on that one. And then we calculate the intersection point. And how many? So it would be 6.8 what? 6.8, what would be our label?
Gigabytes.
Gigabytes, very good. Very good. I don't know if I spelled that right. It's okay. Now, on my decimals here, what would I do to calculate this second one? I would say what to find the intersection point? What would I do?
P of X equals 42 on the bottom.
Oh, wrong. Thank you. Thank you for catching that. Oh, no, I wrote that. I wrote this. B of X
Equals 42.
is equal to 42.1. And I would calculate the intersection point. Very good. So what would be my answer here? When B of X is equal to 42.1, my X would be equal to 1.7. What was it? 1.7? 1 gigabytes. Very good. Very good. And lastly, what did we get for a solution here? Or what would our X be here? 9.125. What? Gigabytes. Boom. Oh, I did 2 X's there. 9.125 gigabytes. Okay. So today, the main focus of our lesson was, yes, plugging in and solving to find some values, but we just learned about another technology tool that we have that we can use to calculate values as well. Okay? So we can graph equation lines in function notation, and then we can find intersection points when we say X is equal to, or Y is equal to, or B of X is the same thing as Y is equal to. You calculate that intersection point. Okay? So, ladies and gentlemen, today we learned some tools that we are going to be using in the future that will sort of cut some time out of it. Because what do you think is going to take? So if I gave you only 2 minutes to do this whole sheet here and you had to do math, like actually plug in and solve, would you be a little bit stressed?
No.
John is saying no because he's so confident in his finger.
I did it in my head. I didn't even use the.
Did it in your head? Stop it. Awesome. Well, for a majority of people, doing some of this decimal work out would be a little bit scary. So, ladies and gentlemen, we are going to be using these graphing technology tools in tandem with solving, plugging in and solving, in order to sort of lighten the load a little bit, okay? So today was sort of a side step as opposed to a step up, because we just learned about a new piece of technology that we can use to assist us moving forward, okay? Awesome job, everybody. Let's take a look at this next piece, this close out, this cool down, okay? College student who is looking for a data plan for her cell phone found a third option, which also offers a 2 gigabyte monthly allowance for data. The monthly cost of this option can be represented by function C, defined by C of X is equal to 30X plus 5, where X is the gigabytes of data used over the monthly allowance. So we're writing a function with the same sort of variables, different name, obviously, because we're talking about a third option. Find C of 0.75 and explain what it means in the context of this situation. Then her budget is still $50 a month. To find out how many, oh wait, we skipped the one that had that. So to find out how many gigabytes of data she could use if she chose this plan, she writes C of X is equal to 50 and solves for X. Like we're finding we're finding that intersection point again. What value of X makes the equation true? Okay. So I want you to do 2 things here. First, calculate what C of 0.75 would be and explain what it means in the context of the story. Then I want you to figure out if she had $50 to spend, How many gigabytes of data could she buy? You can use the graphing tool if you want. You can use Desmos if you'd like. You can plug in and solve if you'd like, whichever you're more comfortable with. Okay, and then your homework for this evening. Homework for this evening is 15 minutes of Alex time. 15 minutes of Alex time, okay? So you can finish up this cool down here, and then you can have the last few minutes of class to, if you want to get started on Alex, you can. Look at that. No, so slide 7 does not need to be completed, no. You're just completing that cool down and then moving into your homework, which is 15 minutes of Alex. Okay. Yeah, wish we never finishes early. Yes, so you're doing that now. You can do it now because we still have time before Spanish. And then you can start to, you can, if you finish with the cool down, then you could go into the homework, which is Alex time.